Hello again, welcome to another lesson in Algebra 1. Today we are covering section 6.4 in our book, Solving and Graphing Solutions to Compound Inequalities. Okay, so we start off with a little notes here, no warm-up today. Statements with an and or. So 6 students are asked the following 2 questions. Are you taking a foreign language class? Or are you taking an art class? And the results are displayed in this Venn diagram. So the first circle here, circle A, represents everybody who answered yes to taking an art class. Okay, so if they're inside the red circle, you said yes to taking an art class. So that's 3 people. It's Taylor, Miley, and Justin. And circle B over here is everybody who answered yes to a foreign language class. That's 4 people. That's Selena, Harry, Miley, and Justin. And then there's one person outside who didn't answer yes to either one, and that's Haley. Okay, so let's answer the questions down below, draw some conclusions here. So first says list all the people who are in set A. So that's the people who took art class. So this is Taylor. This is Miley. And this is Justin. And then it says list all the students that are in set B. Set B are the foreign language students. They're inside the blue circle here. So this is Miley. This is Justin. This is Selena. And this is Harry. And then it says list the students that are in both sets A and B. Okay. Well, if they are in sets A and B, that means they answered yes to both questions. So they have to be in the red circle and in the blue circle at the same time. And that's this part in here. Okay. So this is I take foreign language and I take art class. So this is Miley and Justin. It's the overlap of the 2 circles. Okay. And then the students who belong to set A or set B are all the students who belong to only set A, only in set B. Okay, so only set A would be Taylor. Only set B would be Selena and Harry. And then also the people who are in sets A and B. So that's Miley and Justin. So or is anybody who answered yes to either question. So this is Miley and Justin. This is almost everybody. Who's the one person who's not in one of these sets, the set A or set B? Well, that's Haley. Haley answered no to both questions, so she is not in either set. So you should think of this A and B, this is the important word here, means they have to be in both. So that's the overlap of the circles. A or B is anybody in either one, including the overlap. So everything in here, okay? So this or and is important, okay? And means you have to answer yes to both, or means you have to answer yes to either one, okay? Or both. All right, so we have 2 true-false conditional statements, and we're supposed to figure out if they are true or false. If student belongs to sets A and B, okay, who are the only people in sets A and B? Those are Miley and Justin. Okay, then the student belongs to set A or B. Well, Miley and Justin are also in set A or B. So this is a true statement, okay? Remember, the definition for or B includes and B at the same time, okay? The definition is anybody in set A only, set B only, or the overlap of set A and B. All right, now we're going to go the opposite way. If a student belongs in set A or set B, so that means they're anywhere within this big green part up here, everything in either A, B only, or the combo of A and B, then they also belong in set A and B. And this is going to be a false statement You just pick somebody who's in the only A or only B section for a counterexample. So either Taylor, Selena, or Harry would be a good counterexample. I'll go with Taylor. Okay, this concludes page 1. But if you're really confused later on the and or and why there's a difference, you need to come back and look at this page and look at number 3 and 4 and see if you can figure out what the difference between an and or statement is. Okay, on page 2 here, we're talking about compound inequalities, which extends what we just did about the Venn diagrams. So compound inequality consists of two separate inequalities joined by an and or an or. So something like this. X is less than 1, or x is greater than 2. So we have a compound inequality because we have two inequalities, the part and squared, and they're joined together with this word or. And we can also join with and, so we really need to know what those and or things mean. Okay, so the and is the intersection of those two inequalities. So the place that makes both of them true. So think back to our Venn diagram in our first page here, and the and was the place where the two circles overlapped. The part that was answers to both circles. Okay, so in this case, we're trying to look for what numbers are answers to both inequalities. So our first inequality graphed by itself would look like this: x greater than negative 2. Okay, x greater than negative 2 has an open circle on negative 2 because it's not equal to, and we'd shade everything to the right. And then we have a second one here, x less than or equal to 1. That's a filled in circle on 1, and we shade to the left. Okay. Now, if I ask for the intersection of those by putting the word and in between them, so I'm saying I want to know what are all the numbers that are greater than negative 2 and less than or equal to 1 at the same time. Okay. So what I do is I think of, well, where's the overlap in the graphs? Well, the overlap happens between here and here. These are the things that are answers to both. Okay, so our graph really goes from negative 2 up to 1, with 1 being filled in and negative 2 not, because those are the solutions that match in both. And you can see them here. I'm getting this much from here and this much from here because those are the only two places where the solutions overlap. Okay, so another way to write an and is to combine it into one single statement where we say x is between negative 2 and 1. So negative 2 is less than x and less than or equal to 1 at the same time. So all of our answers have to fall between these two boundaries. It goes from negative 2 to 1. Okay. All right, so let's look at an or one. The graph of a compound inequality with or is the union. So that meant all of the parts. So this meant, like in our Venn diagram before, anybody who only belonged to set A or only set B or the intersection, the A and B part. Now this is a much easier graph to make. Here's our example. So first we graph x is greater than or equal to 0. Okay, so that's the graph of x greater than 0. It has a circle, filled in circle on 0 and shades to the right. And the graph x less than or equal to negative 1 has an empty circle of negative 1 and shades to the left. And the or is anything that's shaded in either one. So you really don't have to think about this too much. You just say, oh, let's see. I'm going to graph greater than or equal to 0. That's that part right here. And then I'm going to also graph x less than negative 1. That's this open circle on negative 1. And I'll shade it over here. And if the two graphs happen to overlap while you're doing them, good. Doesn't matter. Okay? All right. Translate each verbal phrase into an inequality and graph the inequality. All real numbers that are greater than negative 3 and less than 4 at the same time. So we're going to translate it first. There's two ways to translate this. Greater than negative 3 and, they'll always put this in italicized so you can tell which one it is, less than 4. So x is all the real numbers that make this statement true, and we want them to be greater than negative 3 and less than 4 at the same time. Okay. Now there's a better way to write this one. X is going to be sandwiched between two numbers. It's going to be less than 4, but it's also greater than negative 3. And I write that greater than so to make sure it's eating the x, because x is greater than negative 3. Okay. And then we can see where our points go. We want the stuff that lies between negative 3 and 4. So we put an open circle on -3. We put an open circle on 4, and all of our answers that make both statements true come between here and here. So notice everything shaded in here, all of these dots in here, make this statement true. -2 is bigger than -3, -1 is bigger than -3, 0 is bigger than -3, 2 is bigger than -3, 3 is bigger than -3. But it has to stop when we get to 4, not because 4 is not bigger than -3, but because 4 doesn't make the second one true. 4 is not smaller than 4. And then if we go backwards this way, 3 smaller than 4, 2 smaller than 4, 1 smaller than 4, and we have to stop at -3 because not because it doesn't make the second one true, because it doesn't make the first one true. Okay, it has to be in both. All right. Number 2, all real numbers that are less than, so all real numbers is x, and we want them to be less than or equal to -3, or we want them also to be greater than or equal to 2. Greater than or equal to 2. Okay? Less than or equal to -3 or greater than or equal to 2. Now, I like or much better. It's anything in either one. So I just graphed them both at the same time on the same grid. So here's the graph of x less than or equal to -3. And here's the graph of greater than or equal to 2. Because all of our answers are anything that makes this one true, or both of them true. That's all the stuff that makes either one of them true and both of them true, which is no number makes both of them true. Okay. All right, this concludes our second page. On our last page, at an auction, the lowest bid for an autographed card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids on the card. All right, so we'll let x equal the bid amount. And it says that the lowest the card ever went for was 20. So somebody raised their hand and said, I'll bid $20. Okay, so that means the bid has to at least been greater than or equal to 20. And the highest the bid ever went was $54. So x must be greater or less than or equal to 54. So the winning bid was 54. So all the bids must have been smaller than 54. Now, we don't know if every number was bid in between, but we're supposed to write one that describes all the possible bids. So this is fine for an answer, but I like to write my ands as one statement. So I know that the bids went between 54 and 20. Okay, so x is equal to the amount of bid and the bids were between 20 and 54. So this is an and inequality. Okay. All right, number 4, solve this inequality and then graph your solution. So this is an and inequality. It's just written without the word and in it. Okay, so we took the and out and put the boundaries on both sides. And the inside, instead of being x, we have x plus 1. So we're just going to subtract 1 to all the parts. Okay, so for instance, if I covered up the less than or equal to 7 here, we have this inequality that we've already solved before. So we would minus 1 to both sides. This will give us -2 is less than x. But we happen to have 3 sides to our inequality, so we'll also minus 1 to this 7 to get 6. All right, so on your classwork next time, you're going to have to graph these. You don't have to make fancy graphs for it. You put 0, and then you can count out 2, 4, 6, and you can count back -2. And there's a nice, easy graph drawn. Okay, gets everything we need on it. And then we have an open circle on -2. We have a filled in circle on 6. And is anything between these, because and is the intersection of the stuff that is both greater than -2 and less than 6 at the same time. Okay. Number 5, an investor buys a share of stock and will sell them if the change C, the value from the purchase price of share, is less than -3 or greater than 450. So what they do is they buy a stock and they say, and they set an automatic trigger on the computer that says, hey, if the stock goes down $3, I want to sell it. I'm giving up on it. Or if the stock gets up $4.50, go ahead and sell it. I want to take some profit. Okay, so we want to write and graph a compound inequality that describes the change in value for which the shares will be sold. Okay, so an investor buys shares of stock and will sell them if the change C in value is from the purchase price of the share is less than -3. So if it's less than -3, so if the change amount goes down 3, or it goes up, so there's my word or here, greater than 450. So if the change is greater than 450, I'll sell. And as long as it's fluctuating between the two of them, we're not going to do anything. Okay. So this is our inequality. We cannot combine it because ORs have to be written separately. Okay. And then we want to graph it. So once again, I have to make a really complicated graph. There's 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. And ours goes from everything that's less than -3. So I put an open circle of -3, and here's all the stuff less, or anything greater than 450. So there's an open circle in 450, and I shade this way. So as long as the stock change in the stock price stays between -3 and 450, nothing happens. If the stock goes above 450 change, we'll sell it. Or if the stock goes below a -3 change, we'll sell it. Okay. All right. Solve and graph each compound inequality. So number 6, I'm going to add 5 to all 3 parts. And you don't have to show the add 5, but I'm just getting it so that we see where it's coming from. And then we're going to graph this. So once again, we don't have to have a complicated graph. We've solved it. We've got x by itself in its spot. And here's 0, 1, 2, 4, 6, 8, 10, 2, 4, 6, 8, -10. Okay, so my graph is going to have a circle on -2 and a circle on 9. Neither one's filled in because we have no bars on our less than signs. And then we got the intersection of the two things. Okay, all right. So these are both ands down here because they can be written as a compound inequality where there's no word in them. Okay. All right, so here we have a 2-step compound inequality. So the first thing I'll do is subtract 4 to all the parts. We'll get 2y, and I'll subtract 4 from this side, and I'll get 20. And then we'll divide everything by 2, and I'm going to get 3 less than or equal to y less than 10. Okay, so I'll make a little grid here. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll plot 3. 1, 2, 3 gets a filled in circle. And 10 gets an empty circle. And we shade everything in between because our answers fall between 10 and 3. Now be careful with thinking that every and is shaded in between. Sometimes we get an and that's nothing. Okay, there is no overlap between the two things. All right. Flip it over. Okay, our last page here. We have to do same thing, but we have 2 or problems. Okay, so or ones, you just solve each one separately. So on the left side, I'm going to subtract 1 to both sides, and I'll get -6. And then I'll divide by 3 to give me -2. And on the right side of this or, I am going to add 5 to both sides to get 12. And I'll divide by 2 to both sides to get 6. Now remember, if you ever multiply or divide by negative, you do have to flip the inequality on that one. Okay, so this is what we end up with. H is less than -2 or H is greater than 6. So we'll make our grid. Here's 0, 2, 4, there's 6, there's -2. And H less than -2 has an open circle on -2, shade it to the left. And H greater than 6 has an open circle on 6, shade it to the right. So this one is everything smaller than -2. This one is everything bigger than 6. And or in between it, remember, is anything in the left one or the right one or the overlap of them. So this is all this part. Okay, the left one and the right one, and there is no overlap in this case. By the way, if there is an overlap, it will shade the whole graph, or if the overlap might be all going to one side. Okay, all right, you'll see some examples of those in the classwork next time. So here we're going to subtract 1 from both sides to get -4. Okay, and then we'll divide by 4 to both sides to get -1. And on the right inequality, we just have to divide by 5. So we'll get C is greater than 3. So here's our final answer for solving. Everything less than or equal to -1 or greater than 3. So let's make our graph. There's 0, there's -1, 1, 2, and 3. Okay, so everything less than -1 gets a filled in circle on -1. Shade it to the left. And greater than 3 gets an empty circle on 3. Shade it to the right. So or is anything in the right graph, anything in the left one, or anything that overlaps them. All right, so you have a short follow-up here. There are 3 questions. You do a translation and then graph, and then you do 2 solving and graph, and you get to make your own scales on those, okay? Once again, as always, there's the answers on the bottom down here, but please don't just copy my answers, work them out, and see if you can come up with the same thing. If you're not able to do that, then it tells you that you did not learn enough from the notes, and you need to go back and watch it again. All right, I'll see you in class next time.